Afternoon, everyone. Welcome to our webinar where we are going to talk about the effect of weather on your sales. I am the sales manager for SOLVENTURE LIFE. So today we're going to explain how weather can have an impact on your sales and how to include that impact in your sales forecast. So let's take a look at the agenda for today. We will start with a short introduction on SOLVENTURE LIFE. So who are we, what do we do? And then I will give the word to our Managing Director, Professor Dr. Bram de Smet, who will give more information on leading indicator forecasting and the effect of weather on your sales. We will finish this webinar with some time to answer your questions. Okay, so SOLVENTURE LIFE, who are we? SOLVENTURE LIFE is a company specialized in leading indicator forecasting, so in advanced forecasting solutions. So over the past 5 years, we have done elaborated research into including external data into the sales forecast. And so we have a PhD researcher in our team who is now entering his last year of his PhD on this topic, and we've also had multiple master theses covering the leading indicator forecasting topic. So what we've seen is that including external data into the sales forecast has helped us to improve not only forecast accuracy, but we also seen that we gain a lot more insight in the market environment the business operates, and also the business drivers that are important for your sales. So what have we done? We've developed a tool where we've gathered global data from various data sources. So data from, for example, the Federal Reserve of Economic Data, but also other data sources like IMF, OECD. So up till now, we have more than 350,000 external indicators in our database. And what the tool does is it automatically selects which type of external data is related to your sales. And on the basis of the output of that type of scan, we generate sales forecasts to improve our sales operations. So when we look at external data, we are not only talking about macroeconomic factors, but we also talk about events, weather, promotions, legislation, social media, calendar effects. In our previous webinars, our previous webinar in December was about how promotions and events and calendar effects can affect your sales data. The webinar before that, we've talked more about macroeconomic factors, but today we're going to talk about weather and how weather can affect your sales data. Now, the tool doesn't only look at these external influences on its own. It can also combine different types of external data into one sales forecast. So we get one solid sales forecast where we include all the relevant indicators for your type of business. When we look at the different types of industries we have, we see that not all external indicators are as relevant for each of those industries. When we take an example, for example, FMCG types of industry companies, they are heavily affected by promotions and events and calendar effects, whilst these type of external indicators are not as relevant for more B2B type of companies. Now, today we're going to look at weather, and weather can have an impact on different types of industries. Our example for today will be a global manufacturer in the discrete B2B business. Overlooking now what type of references we have here at SOLVENTURE. So we have clients in different types of industries, and weather is important in all these types of industries. So we have companies or clients in the chemical and process industry, discrete and high-tech, food and CPG. Now, a little bit more on how SOLVENTURE LIFE fits into the SOLVENTURE group as a whole. SOLVENTURE has three business units. SOLVENTURE LIFE, the one I am now explaining, on advanced forecasting analytics. So we use global data to provide leading indicator forecasts, and this ultimately results in improved forecast accuracy. But we also have another business unit, the SOLVENTURE s&op business unit. This business unit is specialized in designing and implementing sales, inventory, and operations planning processes. And for that, it focuses on 4 main pillars: people, process, tools, and analytics. And the software we use for that is the Arkiva software. You can find more information on the website, solventure.eu. And then there's another business unit within Solventure, the Solventure Academy. So we've seen that a lot of companies, they already have a good process in place and they might have good tools in place as well, but they lack some experience in the supply chain field. And that's why we started this business unit where we organize accelerator days and boost camps. So the accelerator days, these are trainings on specific topics in the supply chain. So these could be days on demand planning or inventory or supply planning or executive SIOP. And these accelerator days are taking place throughout Europe. Then we also have more tailor-made approaches in our boost camps. So if your company, for example, has some problems within the demand planning unit, we can organize a specific demand planning trainings for your company. Now, this was the introduction on Solventure and Solventure Life. Now I'm going to give the word to our Managing Director, Professor Dr. Bram de Smet, who will give you more information on the leading indicator forecasting and the effect of weather on your sales.
Before we dig into weather information, I want to recap with you what is the approach to include macroeconomic leading indicators, because the weather information in the end is a kind of a refinement on that basic approach. So what we do is, this is an example from a business-to-business company, second-tier automotive supplier. And what you see in the black is the original sales pattern. That has a lot of peaks. When we look for macroeconomic trends or cycles, we typically take out some of the variance, for instance, calendar seasonality. If December typically has lower sales because customers want to build up their stocks, that's not something we want to predict with a macroeconomic indicator. This is basically traditional calendar seasonality, which we remove before we start looking for macroeconomic indicators. And you could consider this as a typical business-to-business example, without heavy weather influence, without heavy influence of events or promotions or so other. If we filter out some of the peaks, what you see here is the filtered pattern or the smoothed pattern. The peaks are gone, but you see level shift. So you see that there is a certain level over here. We make a shift in the level to a higher level, then we drop back. And if we look at how traditional forecasting methods deal with that, well, traditional forecasting methods extrapolate the recent history. So if we assume that we are at the end of this period over here where my mouse is pointing at, if we extrapolate, and because we have removed the seasonality, we're not using a seasonal technique anymore, we're just extrapolating the trend. Well, the trend which will be extrapolated is the recent trend. So if the recent trend goes like this, a forecasting method will just extrapolate let us say a downward trend into the near future. We see, or we know behind the facts that we had a sharp drop here in the sales volume and that bottomed out. A traditional technique will not see that coming because recent history doesn't indicate it. What we also see is that as sales starts declining, if we are suddenly dropping back on the sales, again, a traditional trend technique will overreact. We will extrapolate the recent trend all the way down. Certainly if we take one period further, we see that sales is dropping and dropping and dropping. And a traditional technique will just keep on extrapolating up to minus infinity. You see that the sales bottoms out here. A traditional technique won't see that coming. We will need to wait up to the moment that the sales has already bottomed out before the trend technique will pick that up. So if I continue and if I scroll to the right, so to speak, I see here that, well, the sales has bottomed out. Once the sales has bottomed out, the trend technique will detect it. And in this case, he will predict a slightly increasing trend. and it's going up and down a little bit here, and this is the summary. So you also see that a traditional trend technique will make huge swings. Yeah? So here we just extrapolate, let us say, a mildly declining trend. As the sales is really dropping quickly, we see that we predict quite aggressively decreasing trend. Yeah? After the sales has bottomed out, we again start predicting a kind of a level sales or a slightly increasing trend. That's, to say, the issue we see in traditional forecasting methods. The question, of course, then becomes, how can leading indicators help us to improve the forecasting? And I already mentioned that this specific data set is a second-tier supplier to automotive. Yeah? So what we have also explained in earlier webinars, so we went into quite some detail in our first webinar, of which the recording is available. So if you want to know more, don't hesitate, we're happy to provide that information. When we did the leading indicator analysis, it turned out that for this specific case, it was better to use 3 indicators. We had an indicator really for the short term, month 1 to 4. We had an indicator for the month 5 to 7, you could say the midterm, and we had an indicator really for the longer term. Shorter term really linked to, you say, motor vehicle. Longer term was more linked to oil. If we use this type of indicators or a combination of indicators, what happens? Well, the basic question is, will the indicator help us to better turn the corners? Can I better predict that the sales is going to drop dead and then bottom out? That's what we're after. So let's look at what the leading indicator forecast gives here. So we start forecasting at the same point here. So where the traditional technique was just extrapolating a slight decreasing trend, we see that using the leading indicator better predicts, let us say, the sudden drop. So it helps us to say, well, sales will drop, and it will drop quite aggressively, but it will also bottom out. So you see that we don't predict a decrease up to minus infinity. We predict a decrease and then also the bottoming out of the sales. If we go 1 month further, so if we again scroll to the right, well, we see that's kind of confirmed. Well, the sales will drop and it will bottom out. Here we are already kind of at the bottom. You could say, well, the bottom is a bit too high. Well, I agree, the forecast will never be perfect. The question will then also be, can we also predict that at a certain point the sales will again be picking up again? Well, actually, if we scroll to the right, we see that the leading indicator at a certain point also starts predicting the increase. So it says we're kind of past the bottom, or we still have 2 or 3 months where the sales will be flat and then the sales will be picking up again. So the whole idea of leading indicator forecasting is that where a traditional technique doesn't really doesn't help us to turn corners, the idea of leading indicators is that we are better able to turn the corner. So when the sales all of a sudden drops, we need to be able to better predict that with the leading indicator. When it bottoms out or when it rebounds, those are the points we are really looking at. If we compare, this is again the different forecasts. It's like a rolling forecast. If you remember how the trend forecast went, the trend forecast really went in all type of directions. So we had a slightly decreasing trend, we had an aggressively decreasing trend, we had an increasing trend, and if you looked at the forecast 6 to 9 months out, it was really going all over the place. If you look at the leading indicator forecast, you also see that they are much more stable. And we all know that providing a more stable forecast to your supply chain brings a lot of benefits both to production and to suppliers. So that's also a key element when you use leading indicators. If we compare them 1 to 1, well, this was the trend forecast, this is the leading indicator forecast. Well, it's clear that in this at this time the leading indicator forecast is much better. We've also measured that using the MAPI, so that's an average, the mean average percentage error. So what's kind of the average error that we make? Well, you see that the average error on the leading indicator forecast is much smaller compared to the error on a typical trend forecast. If we continue, well, when we are really here in the steep zone, we see that the advantage is smaller. Also, if I go Here I see it smaller. Yeah? When I'm bottoming out, you again see that the leading indicator forecast is better. Yeah? So the leading indicator forecast predicts the bottoming out, whereas the trend forecast really goes all the way negative. Well, we see that the trend forecast has a MAPI of 21%, where the leading indicator forecast has a MAPI of 6%. And so it's again around a factor 4 better. Yeah? If the sales is flat, yeah, as we go here, if the sales is flat, we see that the difference is smaller. Actually, in this specific case, yeah, the traditional forecast is better than the leading indicator forecast. But that's okay. Our ambition is that we say, well, when sales is flat, we want the leading indicator forecast to be as good as a traditional forecast. Where the leading indicator forecast should make the difference is really when we turn the corners. Yeah? Those are the periods with the biggest uncertainty. That's where we fail. And I've also discussed with a lot of companies in the meantime which say, well, I'm not using statistical forecasting. Well, even if you're not using statistical forecasting, if we go back to the original time period, so if your recent months are kind of a 5% decline in the sales, even if you don't use statistics and you do a bottom-up forecast which is delivered by the salespeople, if the last 9 months were a slight decline of minus 5%, if you ask the people what will happen for the next 3 months, well, they will just predict a minus 5%. So it's not only statistics, it's also human behavior, which is tempted to extrapolate recent history. Yeah? We are quite biased by that. And when turning corners, I think there's another overview coming up. Here we really show for the different iterations of that forecast, what was the MAPI of the leading indicator forecast, what was the MAPI of a traditional trend forecast. Yeah? So you see that some periods are closer. Yeah? So we've given that one example here where the traditional forecast was even better, but that's really when we have flat sales or a constant trend. When we are turning corners, so remember that the first period that's turning a corner, all of a sudden we have a drop in the sales. You see that the leading indicator is much better at predicting the turning of the corners. And also, if you look at the average MAPI over that 9-month rolling horizon, you see that leading indicators is doing a much better job compared to traditional techniques, or let us say traditional bottom-up forecasting, in case you would not be using statistics. We can give you the best indicator, but when we do this type of analysis, yeah, for sure we give you the top 10 or the top 15. So in this case, we chose to work with 3 indicators. These are the indicators in bold. But we can also easily say, like, okay, this was the best one. Yeah? The producer price index by industry. This was the best one in this time horizon. If you would use that indicator also in the month 1 to 4, yeah, you can see what is the forecast accuracy of using it. Yeah? So we chose to use a better indicator, but there will always be a trade-off between complexity and benefit, right? So it might make sense to say, well, instead of using 3 indicators, I really want to focus on one indicator. Yeah? Even if the performance is, let's say, a little bit less, if I can already improve my average error from 15% to like 7.5%, if I can already halve my forecast error, maybe that's already good enough. And doing that with one indicator may be more easy to explain to the people in your organization, instead of going from 15% to 5%, yeah, and using 3 indicators. So that's certainly the type of discussion we are looking for with you as a company if we implement leading indicator forecasting. So all of this was just a kind of a recap on how does leading indicator based on macroeconomic indicators, how does that work? I hope that's clear. If not, we will certainly have time for questions, so maybe write down your question for now and we will come back to it. The goal of this webinar was to say, okay, but how do I include extra effects? For the people who attended the previous webinar, in the previous webinar we talked about promotions. And we have shown how certainly for FMCG companies, promotions have a huge effect on the variability. Actually, the effect can be that strong that companies think that the macroeconomic effects are not important. Well, in the previous webinar, we have shown that's not the case. Yeah? You really need to account for the different sources of variability to be able to come to a good forecast. And okay, if you're in FMCG, promos will be one of them. That's what we discussed in the previous webinar. In this webinar, we want to discuss weather effects. So what's the impact of weather effects and how do we include them? Well, in general, we see there is a double effect of weather. I gave a couple of examples, but you may find some for your own company. But assume you are selling air conditioning. Assume you are selling swimming pools, or you would be selling ice cream. Well, in general, we expect there's two effects of weather. A first important effect is timing. If you have an early summer peak, you will start selling earlier. If you have a late summer peak, talking in European terms, if you would have unexpectedly hot weather in September or early October, that would kind of create a late peak. So the timing of the weather really defines the timing of your sales. So that's certainly a first effect. A second effect is simply the volume. If I have a hot summer, I will most probably sell more air conditioning compared to having a very weak, cold and wet summer. So we have a timing effect, but we simply also have a volume effect. And depending on how important these effects are, well, it may simply be impossible to come to a good forecast, and we will try to give two examples later on. These examples sound very simple. Reality is always a bit more complex than it seems. Just to give you an example, well, let's recap our air conditioning example. Well, most probably there will be a different behavior if I look at consumer products. So many of us might have this type of things in-house. Professional products, which you might recognize from hotels or shopping malls, or industrial products. So if I make air conditioning, I might also make, I don't know, coolers for plastics or coolers for wine or whatever. Consumer products may also depend on the region. If you are in Phoenix, Arizona, well, you will not build a house without air conditioning. If you are somewhere in a central location like Belgium or the Netherlands, Germany, if you're somewhere in those countries of Europe, you will see that not everybody who builds a new house necessarily installs air conditioning. Why? Because summers are not always extremely hot. So you will see that the biggest weather impact will certainly come here from the consumer products in those countries which have, on average, let us say, summers where you can survive without air conditioning. So the weather dependency will certainly be less if you look at professional products. Well, if you build a hotel, you will include air conditioning, right? And whether you buy yes or no will not depend on the weather. The same for industrial cooling, you basically need it. And this might more be macroeconomic in the sense that if economy is weak, there will be less investment, so I will sell less industrial products, but it will be less weather driven. Consumers in general only buy when it's hot. So if it's hot, I buy ice cream. If it's hot, I buy air conditioning. So the dependency here is expected to be the highest. It also means that if you really want to model it, you will need to get a good tool which kind of automates that for you and which detects on, okay, for which product ranges is it relevant, and is it relevant for all countries, or is it only relevant for some countries? And for those countries where it is relevant, it can be really important that you include it if you want to come to a good forecast. That's what we will try to do. Another reason that weather is complex or subtle, well, think of ice cream. Well, summer versus winter effect. Most probably I have peaks in the summer, and the peaks in the summer will be weather driven. But I might also have peaks in the winter. But if I look at the winter, it may not be driven by weather. It may be driven by calendar seasonality. Like, okay, at the end of the year we have Christmas, we have year-end festivities, and people just like ice cream as a good dessert. So I may have a peak in the sales, which is not really depending on how warm or how cold it is. Whatever the temperature, we want to have a good icing or a good ice cream, let's say, as a good dessert around these festivities. So all of these again confirms that weather is not easy to model. We will give a couple of examples, and in general I also believe that that you need good expertise and good tooling to be doing this in a, to say, conscious way and also a good way. Should we care? So is it really necessary? Well, we will show two examples. One is an example from business to business. It's the aftermarket operations of an equipment manufacturer. And well, the expected weather dependency there is the following. In general, we say, well, okay, when it starts freezing, when it starts to get cold, we expect that certain parts of our machine have a higher risk of breaking down and will need to be replaced, right? So we don't see a lot of those replacements being done in the summer. It's really when the first cold hits us, yeah, that's when we need to start replacing stuff. Yeah? That's the first example. The second example is from an FMCG company, and it's about a dairy product. It's not the sales of the company, it's actually the sellout of one of their customers, of a retailer. Yeah? And the weather dependency we expect there is like, okay, if it's hot weather, people will not cook warm. Right? They will instead more look for chilled products that keep their mouth fresh. So that's the second example we will use to, well, first of all, see, is there weather influence? Is there a weather dependency? And then at least for those two examples, we will try to come to a conclusion like, do I really need to include weather information? What is the risk if I don't include it? Let's start with the first example. So again, business to business, it's an equipment manufacturer. We are looking at the aftermarket operation. So it's about the spare part operations of those companies and the service that goes with it. And what we expect is that when the first cold hits a country, let's say a country in general, that kind of leads to a peak of replacements and replacement parts. Okay, this is the sales of the company. We are looking at Switzerland and Austria. So for people who are not familiar with Europe, Switzerland and Austria are quite central, so they can have quite heavy winters and heavy winter peaks. It's known for skiing, and you don't go for ski if it doesn't get quite cold. What we see in this example is two effects. We certainly see calendar seasonality, and okay, we see that the December sales is typically low. Actually, we see that November and December is typically low. Yeah? What's the typical explanation? Well, we go partly direct, but we also go via distributors. Distributors try to keep their stocks low, certainly at the end of the year when we have the fiscal closing. So that's a yearly recurring pattern which is covered by normal calendar seasonality. What is less difficult to see here, but what we will show with the arrows, is that we also expect weather effects. And why is that? Well, there's three peaks in the sales pattern. So there's a big peak over here, there's a second peak over here, and there's a third peak over there. And we see three peaks, and if you look at more detail in the data, actually we notice that these peaks are in October, and this peak is in September. And if you look into more detail, well, you kind of feel that this is the effect we talked about, that when it starts getting cold, we have a first peak. So that's what we are trying to explain using weather information. What happens if we don't include the weather information? Well, remember that we said the first peak is in October. The second peak is in October. So if we are at the end of 2015 and we make a forecast for 2016, when do we predict the peak? We will predict the peak in October. So if I would be using any type of regular seasonal forecasting technique, we predict the peak in October, where the actual sales is happening in September. And of course you can say, well, if I know this is a weather dependent product, then I need to provide the peak, and I can manually adjust the forecast, and instead of putting it in October I can manually put it earlier. Maybe I just need to always put the peak in September. Well, there's a lot of stuff you can in theory correct manually. The problem is that it's not always apparent that you do have a weather influence. That's one. And two, if you rely yourself on a very manual process, you know that it's not always going to happen and that you're going to make mistakes. And what's the mistake we would make if we have not corrected, let us say, the forecast manually? Well, then I have predicted the stuff for October where I actually have a huge peak in September. So you see, this is the peak I have in September. What would be a traditional forecast for September? It's just over here. So you can imagine, if you have not foreseen the peak here in September, it's a drama. You will have a huge issue in supplying the market. You will have a lot of firefighting, and it will give a bad image in the market, because maybe you have forgotten to manually correct. If you have forgotten to manually correct, and your customers expect that this is a product which is linked to a first winter peak, you will just create a poor image of yourself in the market. So we are a big fan of automating as much of this stuff as possible. Analytic techniques are available for that. What happens if I would forecast 2017 based on the data from 14, 15, 16? That's the second question. So this was what happens if I forecast 16 based on the first 2 years, where the peak here was in October, the second peak was in October. Well, then of course I would predict a peak in October. What happens if I'm in the following situation? I'm at the end of 2016. I now make a forecast for 2017. Well, the peak here was in October, the second peak was in October, and the third peak was in September. Well, if you use a traditional forecasting technique, what you will predict is a kind of a blurred peak. Because sometimes it was in October, sometimes it was in September, actually the last year. If peaks are shifting due to the weather, what you will end up with in your forecast is a blurred peak. This is an example of a regression technique. This is an example of the Holt Winters technique. So also over here, you see a kind of a blurred peak. So any traditional seasonal technique, when the peak is shifting, will result in blurry peaks. Blurry peaks are bad because it means you simply will have too much in one month and you will not have enough in another month. Assume that the month that the peak would again be in September. It would be an early winter peak here. Well, again, you would not have enough material available. So predicting blurred peaks is probably not an option. We really want to get this right. How do we do that? Well, we include weather information. How do we include weather information? Well, let's plot minimum temperature. How do we plot minimum temperature? It's over here. Okay, this is minimum temperature per month. What do we see? Well, we see big seasonality, right? And we see that the minimum temperature is highest in the summer, and that the minimum temperature is the lowest, let us say, around the year end. We also see that the minimum temperature is different. So minimum temperature 2014 is over here. Minimum temperature December 2015 is over here. So 2015 was a stronger winter compared to 2014. I also see differences in the summer. So I see that the minimum temperature in 2014 was lower compared to the minimum temperature in the summer of 2015. So the minimum or in general, 2014, the summer was a bit cooler compared to the summer of 2015. This is the example for Switzerland and Austria. If we would make this type of graph for a country like Spain or a continental climate like the UK, you probably see big differences. So that's another challenge when you include weather information. The weather may look different in different parts of a continent and different parts of the world, and you really need a way to automate this. Okay, if you plot this, you don't see anything, right? So let's try to remind ourselves what the effect is we expected and what we were looking for. We said, well, we expect that when it starts getting colder, that specific parts break down and we get a peak in the sale. And the peak in the sales was over here. This was the peak in October, another peak in October, and we had a higher peak here in September. That's the thing we are trying to explain for this business-to-business example. So after some analysis, what we've seen, well, that if we plot a line, and the line is here just for convenience, not 0 degrees Celsius, but it's 0.5, so it's close to freezing, let's call it like that. Let's see what happens, right? And we will also zoom in here really on the focus periods, if you're not sure if that's visible via the GoToMeeting, but the first line here is September, so this is September, the second line is October, so we now clearly see that this is September, October, September, October. So in the last year, the peak shifts to September. Let's see what happens to the temperature. Well, if I look at 2014, I see that the temperature here in September is still quite mild, right? So this is the minimum temperature of September. It's still significantly above the 0.5 degrees. We see that in October here, the minimum temperature drops below the 0.5. So it seems like September in 2014 was still a quite mild month, and then October is when it started freezing. And we also see that, okay, it starts freezing here in October, and that generates potentially a peak in the sales. Let's see what happens in 2015. Again, September is quite comparable. So the minimum temperature of September was slightly lower compared to that of 2014, but it's still positive. No freezing or close to freezing whatsoever in 2015. If we look at October, we see that the minimum temperature in October dropped to the 0.5 degrees. So, and again, we expect that that first freezing or that first cold triggers a peak in replacements of specific parts. If we look at 2016, we see it's different. If we look at September, we see that September 2016 was already quite cold. And again, this is for specific countries. This is for Switzerland and for Austria. So we see that where in the previous years, September was quite mild. Now in 2016, September was already quite cold. So we can really expect that because in September it was already cold. That first replacement peak of specific parts was done in September. So that's what we clearly see here. So by analyzing data in this way, we kind of already visualize that there is that weather dependency. So how do we include it in the model? Well, we can easily model it and say, okay, the first time the minimal temperature drops below a certain threshold, could be 0 degrees, could be 1 degrees Celsius. Well, we model that as an extra effect. What happens if we model that as an extra effect? Well, that's what we see over here. So we see that if we model that effect, we can explain those peaks extremely well. It's almost impossible. It's almost too good to be true. I see that I really predict the peak of sales here in October. This is the peak in October, and okay, I say if the temperature drops earlier, if it drops below 1 degree Celsius already in September, this is what you're going to have. And a very interesting effect is that it struck me the first time I saw these results that we have peaks here in October which are almost identical size. It struck me that the peak in September was higher, not usually higher, but still higher, and that by modeling that event, at the time we drop below 0, we get an extra peak in the sales. We see that September, we also match that higher peak compared to the lower peaks over here. And what you actually see there is a combination effect. The fact that September is higher compared to the earlier peaks is not due to the temperature, because we just model the 0-1 effect. Like the first time the temperature drops below a certain threshold, it generates an extra peak in the sales. So that peak is the same. That's not explaining the higher peak. Yeah? What we really see here is an interaction effect. We say, well, the fact that it's September and that in September you hit the first winter type of weather, yeah? The combination of the two results in a somewhat higher peak. So we can also model those interaction effects. Okay, now we've added, you could say, one winter effect, which already helps us to explain the timing, right? Is the peak coming earlier or is the peak coming later? Yeah? So we get some stuff right, but some stuff is not yet right. So if you look over here, well, some things are really overstated. If you look at the peak like this, we don't really match it. This one could be improved, this period could be improved. So we got the peaks right, but there's still a lot of stuff we don't get really right. So next step could be like, okay, what else can the minimum temperature explain? Yeah? And instead of just modeling that first winter peak, what if we would, in general, add temperature? Because we already said, well, there will be a timing effect, yeah? And maybe that first winter peak is an extreme example, but there will also be a volume effect. Well, if we add the minimum temperature of the month as an extra variable, yeah, we see that some peaks are significantly better predicted. So if you look at this one, this peak over here, so this peak is understated. Yeah. If we add the minimum temperature of the month, you see that the matching is much better. The second one is over here. You see that this peak is overstated. Yeah. This peak is overstated. Yeah. Here we really understate. Yeah. If we include that information, yeah, we see that the first peak we much better, yeah, the second peak we don't, we still don't get it right. So there will always be remaining variability, things which we can't explain. If the remaining variability is low, maybe it's acceptable. So if you say over here, well, some of this variability we don't really get right, well, maybe if the variability is limited, it's acceptable. If we really miss big peaks, yeah, then probably we miss a demand driver. So if you look at this one over here, well, this one is really too far off. Also, if we look at this one, well, here for one reason or another, we predict the peak, yeah, which is actually not there. So we need to find out what is really happening. And yeah, so next to modeling weather or modeling promos, what we also do as an iterative approach is outlier detection. Yeah? So if we run an outlier detection, we detect the big deviations. Yeah? And if you would start from zero, if you don't model any weather, any promos, yeah, then you would have a lot of outliers. And we do an iterative approach. So if we know there's promos, you need to model promos. If you know there's weather effects, you need to model weather effects. Yeah? And then keep on running outlier detections, yeah, to identify possible exceptions, yeah, so that you can investigate like, what happened here or what happened there. So here we underestimated, here we overestimated stuff. Yeah? And you can correct for it, because maybe you said, okay, well, actually this was a promo. Yeah? Maybe I tried to clean up some of my older stock, and to clean up some of my older stock, I did a promo with one of my distributors, because if I want to get rid of, let's say, cold dependent products around May, well, it's not going to happen because of the weather. If I want to get rid of stuff, maybe I need to do a promo. Well, if you know it's a promo, but you have not, let's say, modeled it like that before, the outlier detection will bring it to your attention, and then you correct it. And by including it, it's an extra demand driver that you can take into account. Okay, so linking that back, let's say, to the macroeconomic forecasting, well, in general, as we explained with the promo forecasting, yeah, if you want to detect macroeconomic patterns, you need to get rid of variability. Yeah? If you know that some of the peaks are really due to weather information or are really due to promos, you need to model the promos, you need to model the weather to take that off. And if you take it off, you are able to reveal the underlying macroeconomic trends. Once you reveal the underlying macroeconomic trend, we can make a macroeconomic forecast, as we have shown in the beginning of this presentation. If you predict into the future, well, for promos, we already said, well, for promos, you probably have a plan, yeah? Or you can say, well, if these are the promos we are going to run, what will be the impact of the promos on my sales. That's what we also have shown in the previous webinar. If we look at the weather, well, I can't predict what the weather is going to be for the next 12 months, right? So how do I deal with weather? Yeah? Well, it's quite easy to get weather information of over the last 30 to 50 years, depending on the weather station you're looking or using as an example. And we can't predict what the weather is going to be, but we can say, well, this will be the average weather pattern. This will be kind of the 5th percentile, and this will be the 95th percentile. So you have only a 5% chance that it will be colder like this. You have only a 5% chance that it will be warmer than this in your winter period. So we can easily model the median, and we can easily model the 5th and the 95th percentile. And based on that, we can run scenarios. So we can show you, like, okay, if it's an average winter, this will be the sales. If it's a strong winter, this will be the sales. If it's a very mild winter, this will be the impact on your sales. And the timing effect is, of course, also difficult to predict, but it's more easy to say, well, if you know that something is weather dependent, well, then always put the peak the earliest possible. So always put the peak in September, because we'd rather have it too early than have it too late. If we have it too early, it's quite probable we will sell it out one month later. If we have it too late, it will just negatively impact our sales figure and our service, and that's something which we don't want. Second example, which will be quite short because we want to leave time for questions, is from an FMCG company. Sell out of a dairy product, and so the black line is the sales of the product, and we took a slightly different approach here. So this is daily data, and you see a kind of a pattern in the week. What we expect is that we say, well, we sell more on Friday and Saturday and Sunday compared to a Monday, when people need to go to work. And we try to gradually explain variance in the pattern here. So if I just use what's the trend, what's a kind of a level, the average sales, and what's a kind of a trend, well, there's an almost unnoticeable, slightly decreasing trend here, and a certain level. What happens if we add the day in the week? This is what happens if we add the day in the week. So you see a kind of a nice sawtooth, which tells us, well, you sell most on a Saturday, you sell less on a Monday. This is an example from a retailer which typically has no openings on Sunday. What else can we add? Well, in general in retail we see that there is an effect in the month. The first week of the month is better compared to the last week of the month, and it has to do with the buying power of people. The last week of the month, some of the lower incomes have no disposable income left, so typically they buy more stuff in the first week of the month. You can also have the month of the year. That's the typical calendar seasonality. Well, if we add that, we get to this level of variance. And it's surprising how much we already explained just by calendar effects. So this was just the trend, so to speak. This is the day in the week. And this is what happens if we add, well, which week in the month is it? Which month in the year is it? Which month in the quarter is it? And so on. So this is just adding calendar effects. And we see that we have a certain pattern coming up, but we are missing big chunks. So if you look here in the beginning of the year, it's clearly overstated. If you look here second half, here it seems to be understated, right? So the question is, how can we correct it? And this is when we include the weather effect. And again, the first time I saw this example, I was shocked. I was amazed, because, well, this is not ice cream, right? It's a dairy product. It's not ice cream. So if you look at this peak, just to give an example, so we see a peak over here. If we add weather information, see at how good we match it. Look at these peaks over here. So this is really summer period. If we include weather information, see how much better we model these peaks. Look at the beginning of the year here. So here in general, if we only look at calendar effects, we overstate. If we include weather information, you can really see that we drag the level down. So we bring it much closer, let's say, to the baseline sales. And well, if we look at this type of example, for me it again confirms like, okay, this is not ice cream, this is a dairy product. I really dare you to ask yourself the question like, how can I ever make a forecast of this dairy product without including weather information? It's nearly impossible. And it's the same for the business-to-business example we have given. Yeah? I have seen the timing effect. There we had a very strong timing effect, right? We also had a volume effect, but it was less strong. Yeah? I think here we really see both. I see a volume effect. I see a big peak effect. So I would say a big timing effect. Yeah? And trying to come to a conclusion, well, should we model weather effects? I think in general the answer is yes. Yeah? Like any company has seasonality, calendar seasonality. Why? We sell less in August, we sell less in February. Why do we sell less in February? Because it basically has less days. Yeah? As any company has calendar seasonality, my expectation is that any company has weather dependency, right? And if you want to improve your forecast, you need to model the weather dependency. Yeah? You can easily model based on the past, and if you extrapolate into the future, you can do it in a scenario perspective. So the average forecast will be based on the median weather, and then we can model the percentiles and see what will be the upside and the downside. Yeah? And if we model weather effect, that's a second lesson learned from the examples here. Yeah? As we model promos on a customer SKU basis, that's what we discussed in the previous webinar, I also believe that if you model weather, you preferably start from a daily basis. Yeah? We've seen from that FMCG example how huge the peaks are really on a daily basis from those weather effects. Yeah? We've shown from the business-to-business example that it is possible to do it on a monthly basis and to do it on sell-out, but sell-in, yeah, but preferably so you do it on a daily basis. You do it based on sell-out information if you would be working with distributors, or point of sale information if you would be working, let's say, more with retailers or more in FMCG type of environment. So that's what we had foreseen as a webinar, and I think we're happy now to pose for some questions. We have a first question here. Can you explain the difference between the calendar effects and the weather effects? Well, there could be a correlation between the two. I think, as we also shown with the minimum temperature in the winter will always be lower compared to the minimum temperature in the summer, right? So let's say the calendar seasons and the weather will kind of go together, yeah? And they are also different, as we have shown in the timing effect, like for that winter or for that temperature dependent product in the business-to-business case. Yeah? When it drops below a certain threshold, that's where it really makes a difference. And how do we in general do it? It's interactive. We have a tool, we have capabilities to model that, but we will need to get your assumptions, and you know your products better than we do, so we typically look for a kind of interaction on what are your expectations, then test that whether we can kind of statistically validate your assumption, and once we have statistically validated the assumption, we include it in the forecasting model, and in general we combine weather effects and calendar effects there. Another question coming up here: how do you combine these different external indicators like promotions, events, macroeconomic indicators? What we strongly believe is that the field of forecasting is about to drastically change, right? In the past it was about who has the best technique, and we believe that in the future the competition will be on who has the best information. Yeah? And so in the past most of the techniques were extrapolation techniques, looking at the recent history and then extrapolating. If you want to include external information into your forecast, you do it using causal methods. So causal methods which can, let's say, base the forecast on the behavior of other variables. And other variables could be macroeconomic indicators, could be temperature, could be promotions, could be a calendar, like let's say a recurring calendar, or shifting calendars like Chinese New Year or Easter. Yeah? And that's a very good fit with statistics and techniques like regression. So specifically the techniques we are using are regression techniques coming from statistics. And the good thing is that with regression you can include any type of information. There's in theory no limit. The biggest limitation will be in how good am I in structuring that information. Can you include promos? Yes, you can, but we need to have a good history of your promo. So when did you do a promo? How long did it run? Which type of promo was it? The same from macroeconomic information. Can we include it? Yes, but we will need to have the macroeconomic indicators. And macroeconomic indicators, that's something we have available in our database, so that is something we can provide. And managing that information then becomes more important, but once you have the information, we can define the dependency, and we can also include it into the future forecast. I think time is around up, so thank you for joining. I hope you enjoyed. If you would have any questions whatsoever, don't hesitate reaching out to us. Stay tuned for next webinars. Thank you.